Relationship between f as well as r is f is equal to r divided by 2 is the relationship between this equation. Suppose if there is a formation of image of an object, minimum of 2 rays are must and should. It's left to you how you exactly plot a ray. Components of the spherical mirrors are nothing but the skeleton of the mirrors, like how exactly we have to go on with it when we form an image of an object. Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 2 of chapter 9, and chapter name is Ray Optics and Optical Instruments. In last class, we had studied about the reflection, about the light, that is an introductory concept, laws of reflection, and the spherical mirrors. We have concave mirrors as well as convex mirrors. Having all those concepts, we have studied about the components of the spherical mirror like pole, radius of curvature, focal length, focal plane, principal focus, principal axis. All these things were studied yesterday. So in today's class, we are going to study about the relationship between two components, that is focal length and radius of curvature. So as you all know, you have a mirror. Suppose I consider a concave mirror whose exterior curve is completely silverized or it is polished, and the one which is responsible for the reflection is the interior one. This is center of curvature. So this will be the radius of curvature. So this will be F. So radius, we have to find the relation between F as well as R. What is it exactly? So there is a diagram. Again, draw the diagram over here, and you have got the one side silverized or shaded part. You have center of curvature over here and the principal axis which is passing through it. Components of the spherical mirrors are nothing but the skeleton of the mirrors, like how exactly we have to go on with it when we form an image of an object in front of the mirror. So we have center of curvature which is placed over here, and here that is between two of the, this is a pole. Between pole and center of curvature, we are having the principal focus F. So now the ray, according to the rules which we will be studying a bit later, it is like according to the rule, any line which is coming parallel, any incident which is parallel to this principal axis, it pitches, that is, it is reflected through a point F. That is a principal focus. This is a rule. Any time if any parallel light parallel to the principal axis should come and reflect on the point, that is the principal focus. So your direction is said to be in this manner. It comes and it gets off. So here you have got angle which is made as theta. And if you draw a normal between this incident ray and the reflected ray, according to law of reflection, you have this as I and this as R, reflected ray. So we have a theta covering which is over here, and this can be given as 2 theta angle, and here we have just a normal line which is drawn to the principal axis, call it as point D, and the point of reflection is said to be M. If suppose the naming is done like this, and if you have got a ray called as AM, okay, starting is A and ending is M. So you have A point, M point, C point, F point, D point as well as P point. Now, if suppose you consider one set of triangle MCD, that is MCD, which has angle theta, another set of angle triangle MFD, angle MFD. So consider this as 2 theta and apply a tan function to it. So tan theta is equal to, we have got tan theta is nothing but Opposite by adjacent. So which is the opposite? This is hypotenuse, opposite adjacent. MD divided by CD. Again, we have over here tan 2 theta is equal to MD divided by FD. So we have this set of equation. Now, since this D is very close to point P, it is very near to point P. So when that is the case, you can just approximate your tan theta. That means your theta will be too very small. That is the angle between that. So tan theta is approximately equal to theta, and tan 2 theta is approximately equal to 2 theta. So this can be rewritten as, the equation over here can be written as theta is equal to MD divided by CD, and 2 theta is equal to MD divided by DF or FD. So now we will have to divide two set of equations, this as well as this. That is, divide this by this. So we have 2 theta divided by theta is equal to, for 2 theta we have MD divided by DF. For theta we have MD divide by CD, CD goes to the numerator, so we write like this, MD cancels with MD, theta cancels with theta, so we have 2 is equal to CD divided by DF. What is CD? C and D altogether it is R, as I have mentioned over here, C to complete till P, CD, or it can be calculated as CP also, because D is very much near to P, so it can be considered as P. So from C to P it is R, so I can just consider 2 is equal to R divided by, what is your DF? DF can be either equal to PF, and PF is always the focal length determined with the help of a small f. So I can write this as small f. So f goes here in order to check the relationship. So f is equal to 2 comes down, R divided by 2. So half of the radius is said to be focal length. That is, half of the radius, this is the radius, half of the radius is said to be the focal length, and however it is true. So relationship between f as well as r is f is equal to r divided by 2 is the relationship between this equation. So you'll have to keep it in your mind, because this is very much useful in solving the problems. If you have to find out the value of f, that is the focal length, and you have r in the given, then it is very easy. In order to find out the focal length, you will have to take out r, because the relationship is f is equal to r by 2. So this is most important thing. How we derive this? That is by this set, considering tan function as well as two of the triangles. Since D is very much nearer to P, it is equated as approximately theta and 2 theta, and then dividing it and substituting for the values. That's all is all about this derivation. Next, we are coming to rules for image formation. Yes, for each and everything, since it is like we have got rules. Okay, we just brush our teeth, we wake up early in the morning, and we get ready, we go to school. All these things are set of rules, like we wake up, we fresh up, we get ready, and we wear our uniforms, we wait for a school bus or the school van, and finally we just get into it, correct? So when this is a case, there is certain set of rules which you follow regularly. Similarly, for this formation of image also, there is certain set of rules. And how is that followed? It is followed with the help of these conditions. So what are these conditions? Let us see. A ray from the point which is parallel to, remember, if a ray is parallel to the principal axis, that is, if this is, I'm considering in case of concave, when I'll explain in case of convex also. So here we have silverized at one part, and this is a principal focus, and this is nothing but a concave mirror. Okay, so a ray from the point which is parallel to the principal axis. Suppose this is a ray which is parallel to the principal axis, and the ray determination incident is in this way, and we have got a point, call it as F, and here we have got C. This is a part of the sphere which is being cut and it is taken. So center of curvature is this, where in the between center of curvature as well as pole we have your focal length. So any ray which is parallel to this red line, that is the principal axis, then after reflection it has to pass through principal focus. That is the main condition over here. This is one set of rule. Similarly, for the convex mirror we have, that is, if suppose this is a convex mirror and we have got the inner curve shaded or silverized, and the one, this is called as principal axis, here we have got pole, here will be somewhere center of curvature, between pole and center of curvature it is called as F. This should be the focal length and it is represented by capital letter F, which is known as a principal focus. When this is a case, how exactly the image formation is done? Since the part of the reflection or the surface which is available for the reflection is the exterior point, your ray comes parallel to it and it has to fall through the principal focus according to the rule. But here in this case, it appears, we just imagine the virtual effect, we just imagine, okay, it is not a real one, it's a virtual concept. So we just imagine that it is passing through the principal focus with the help of this dotted lines. But the extension of this dotted lines is been given in this manner, so we just get to know incoming rays, outgoing rays. So this is how the reflection takes place in case of the convex mirror. So since it is shaded or silverized, we just assume that it passes through the principal focus, and correct exact to this dotted lines, we just draw a line so it just pitches out from this point of intersection over there. Clear? So that is how you just form a mirror images in case of concave as well as in case of convex over there. Next is the ray from the point which passes through the center of curvature. If suppose the ray, it is not parallel to the principal axis, but it passes through the center of curvature. Let us see how well we can go with it. A ray from the point which passes through the center of curvature, we have, if this is concave mirror, with the principal axis, this is a pole, this is the center of curvature, and this is focal length F. And here again we have a convex mirror which is silverized from one side, and we have the principal focus, center of curvature, here we have pole, between those two we have F. So we'll have to see the image formation when exactly the incident light falls on the center of curvature. So when the ray of light passes through the center of curvature, incoming, the outgoing also will trace the path backwards. Similarly, in case of concave mirror, when there is F and C towards the other end of the mirror, there will be F and C towards the reflecting end of the mirror as well. So you can just consider this as F as well as this as C. It can be in this way also. So now, if suppose there is a ray which is passing through the center of curve, we can't pass any of the ray like this way. So if there is any ray which is passing through it, we can just give it in this way. Incident. Actually, the line is not straight, it is curved, but the incident ray is always a straight line. So a straight line is moving, that is incident, it reflects back, that is traces back its same path. So it will be this direction. So remember students, suppose if there is a formation of image of an object, minimum of 2 rays are must and should. It's left to you how you exactly plot a ray, but minimum of 2 rays are must and should. Either you can take the ray as parallel, depends upon the distance of the object where it exactly is placed. Either it is between F and P, or it is between C and P, or it is between C and F. It depends how exactly the image is placed. So, depending upon the position of the image, you will have to attempt for 2-ray diagram. Either this and this, like that you will have to refer for. So, when you have 2 rays over there, the intersection point of 2 ray will be your image where exactly it is formed. That's all about your second point. What happens when the ray moves from the center of curvature in case of concave mirror? or it appears to pass through the C of the convex mirror and the reflected ray will trace the back. That is, the reflected ray will always trace back the path taken by the incident light. Next set of rule is like the ray passing through the principal focus. Principal focus is in the case of concave and it appears to pass through F of convex mirror, the reflected ray is parallel to the principal axis. This is the opposite of the first thing whatever we had done. What we had told, if the ray is parallel to principal axis, it has to pass through principal focus. But now it is like if the ray is passing through the principal focus, it has to pass parallel to the principal axis. So in case of concave and in case of convex, we have, if suppose this is called as P, this is called as F, this is called as C, and here also we have pole, F and center of curvature. You can just mention this also as F and center of curvature. If this is a case now, suppose if there is a incident light which is falling onto the principal focus. The incident, it is passing through the principal focus, incident light. If it pitches, it will have to pitch parallel. So it is outgoing in a parallel way. But the previous case was opposite of this. Similar way goes up to your convex mirror where exactly the reflection is taking place. So suppose if this is the focus, so it is like your incident light is coming this way. That is, it appears to hit this focus, but it exactly doesn't do that because always convex mirror is like virtual effect. Appears, that's all. So later it is like it has to go follow the parallel path to this principal axis. So this is the concept of your third law, that is a ray which is passing through the principal focus in case of concave mirror as well as appears to pass through the F of the convex mirror, the reflected ray always emerges out parallel to the principal axis. That's all is about your third point. Finally, the ray incident at any angle at the pole of the mirror. At any angle, if the ray is incident on the pole of the mirror, it follows the law of reflection. So what is the law of reflection? It is like angle of incidence is equal to angle of reflection. Concept has been provided over here and this follows that equation. So we have, I'll just consider one mirror, that is principal axis. So here you have got your pole, here it is F, here it is center of curvature. When this is a case, you have got your ray which is passing. Suppose if there is an incident ray which is incident on the pole, it again reflects back. Incident ray, reflected ray. So this I and this is R. So this is law of reflection concept. Angle I is equal to angle R. That is all about your rules for the image formation. And next we are clicking on to the mirror equation. So what is meant by mirror equation? Mirror equation is the equation which actually gives something about some description about something more, that is a quantitative analysis of the object as well as image, or the size of the object as well as image and its position. So this is why this mirror image is very, very, very useful. So in case of this mirror equation, we have to have a mirror and I consider a concave mirror over here. So suppose if you have a concave mirror which is having a principal axis and this is said to be pole. Here you have F, principal focus, here you have center of curvature. And now this is a ray diagram. And in order to have a ray diagram, I need to have an object because I need to know where exactly the image is placed. You have already studied in your 10th standard like how exactly to form a ray diagrams. So having that concept as a basic, I'm not going to do it once again. It's like a basic knowledge what you should have when you just come into this, where exactly the object is placed. If the object is placed between so and so, between this distance or in between this gap, where exactly the image has to be formed. That is actually the concept. So now let me consider the image formation which lies between C as well as F. That is, the object is kept between C and F, that is the center of curvature as well as the principal focus. So now suppose if I have an object which is over here. How will you draw the ray diagram? I told you we'll have to follow up any 2 rules out of those set of 4 rules, whatever I had told you. Out of 4 rules, follow any 2 rules so that you will get the image formation in a clear way. So if suppose our object is like this, how is the set of ray diagram what you draw? If you have got a ray like this, that is the object is present over here and 2 set of concepts, that is 2 set of rules you'll have to follow. So if the incident ray is parallel to the principal axis, it passes through the principal focus according to the rules. Now either you can take the ray incident from the pole to here, or else you can directly take the center of curvature. For me, I'm okay with taking the center of curvature. So if suppose this is the extension of the mirror, so you will have some rays which is passing through the center of curvature. So the point of intersection is this part. So to this part, this is a head arrow which has come like this, and this is a head arrow which is coming like this. So you will have an image which is enlarged and it is beyond C and inverted. Okay, so we have image over here and object over here. Call the object as OB and image as IM, and draw a perpendicular line to the principal axis. Call this D and call this part as T and call this point as ES. So you have TD as well as ES. So the overall thing is completely covered. So here there is an angle which is made, that is call it as theta. So what is this set of equations we are having? OB is nothing but the object. IM means nothing but the image which is formed. So we have 2 set of triangles over here. Let me just tell you correctly like what is the set of triangle that we are considering. This set of equation, that is we have got a small set of equation over here, that is IMC. So we have MIC and OBC. This will be a small set of equation, that is a triangle what we are considering. So it is in this way, O, B, C, M as well as I. We have shaded in this manner. Okay. Next will be our MIF and TDF. So it will be completely this set of equation. This set of triangle is been completely taken off. So I can draw this in black, that is you have MIF and TD. So it is T, here it is D, here it is F, here it is M, and here it is I. The line which is passing through C and the line which is passing through F is being taken. For here I have drawn in this way. So when these 2 set of equations are there, we will have to plot our equations for it. Let me just go with it. Now we have, according to this triangle, we have got theta over here. So according to this triangle, we have OB divides IM. So OB divided by IM is equal to BC divided by IC. BC divided by IC. Call this as equation 1. And the next equation is said to be TD divided by IM. I'm considering this divided by this, and finally I'll go with this section. Similarly, TD divided by IM is equal to FD divided by IF. And we know that by this set of equation, that is TD is parallel to OB. So since TD is parallel to OB, instead of TD I can consider OB. So I'll write it as OB by IM is equal to FD by IF. Equation 2. We have equation 2 and equation 1. Can we equate this section as well as this section? Yes, we can do that. So we have, after this I'm just writing out here. So therefore we have BC divided by IC is equal to FD divided by IF. So this is the set of equation what we are having right now. Call this as equation 3. Okay, so now write certain given terms. That is, the given terms are what we know. It will be, what is your BC? It is, we want all the values for 1, 2, 3, 4. So which are the values we have to opt for? BC, IC is equal to what? This is equal to what? FD is equal to what? And IF is equal to what? In order to have that, we know what is image, where exactly the image is placed, where exactly the object is placed, and where exactly the image is formed and all. So it is like your PF is nothing but, let me write here, PF is nothing but small letter f, that is a focal length. P to C, PC is nothing but capital letter R, radius of curvature. Then you have PB, P and B is nothing but the object where exactly it is placed. So object placement is given by small letter U. And PI, P to I, it is nothing but the image where exactly is formed. Always the image formation is given by small letter U. So this is the set of quantities what we are having. Having this concept, we will have to opt for BC. In order to calculate this BC, I have to take PC minus PB. If you are taking the full term and subtracting only PB, it is PC minus PB, you will get this BC. So it is PC minus PB. So what is your PC? It is R minus what is PB? It is U. And R is nothing but 2 times the focal length, correct? So you can replace your R by 2F minus U. Next, what is IC? IC, in order to have this set of equation, you have to take the full and minus your PC so that you will get this coverage. So IC is equal to PI minus PC, which is equal to, what is P to I? It is V. PI is V minus PC is R. I can take it also as 2F. I'll write 2F. Next is DF or FD, which also can be called as PF. DF or PF because D is very much closer to P. So I can take it as PF. So PF is a focal length, or PF or DF is a focal length. I can write only F. Lastly, it is IF. So what is I and F? IF is nothing but PI minus PF. PI minus PF. So what is PI? It is V minus what is PF? It is F. V minus F. And so this 2F minus U, V minus 2F, F, V minus F, all these are the set of equation we have to apply for equation 3. So we had the equations as, let me rewrite the equations. BC is equal to, we have 2F minus U and IC as V minus 2F, FD as just F, and IF as we had V minus F. Having this set of equation, we will have to equate for the equation, that is equation 3. It will be like BC, equation 3 I am rewriting over here, FD divided by IF. Apply for equation 3 on substituting. I have 2F minus U divided by V minus 2F is equal to F divided by V minus F. Let me just cross it over and multiply. So V minus F, 2F minus U is equal to F into V minus 2F. I have multiply 2F into V minus 2F square minus UV plus UF is equal to VF minus 2F square. So just equate all those things. So minus 2F square, when this comes towards the other side, it becomes plus, and this cancels with this. So you have 2FV minus UV plus UF. Take this also towards the other side, minus VF is equal to 0. So plus FV minus VF, you can just equate it as 2 minus 1 is 1, 1 FV, and here you can just equate these two as minus UV and plus UF is equal to 0. Now it will be like UF plus FV is equal to, you can take towards the other side, it will become UV. Divide throughout by UVF. So UF divided by UVF plus FV divided by UVF, which is equal to UV divided by UVF. You will have U cancel with U, F and F cancels, V and F cancels, and VF cancels, UV cancels, UV cancels. So it is 1 divided by V plus 1 divided by U is equal to 1 by F. So either you can just rewrite it as 1 by U plus 1 by V is equal to 1 by F. This set of equation is said to be the final one, that is the mirror equation, which is an important derivation as well. So you'll have to remember this expressions in order to solve the numericals. Finally, we are heading on to the linear magnification. You're magnifying, that is, you're identifying the size. So it is the ratio of size of the image to the size of the object. Magnification is written as ratio of size of the image to the size of object. So this is how you give. So magnification, size of the image will be V and size of the object will be U. M is equal to V by U. This is how you identify the linear magnification in case of the mirror images. Okay. So in today's class, we have studied about the relation between focal length, as well as we have studied about the set of rules, that is 4 set of rules, how exactly the image formation is taking place. And finally, we have studied about the mirror equation, and at the end, it is linear magnification. Let us all meet in the next class with the upcoming sessions of the same chapter, chapter 9. Until then, have a good day. Thank you.